Welcome back! In this video, we are going to cover the Lorentz force experiment. Let's jump in. Lorentz force is the magnetic force exerted on a moving electric charge by a magnetic field. Lorentz force law is named after the Dutch physicist Hendrik Lorentz, who formulated the equation. The Lorentz force law adds to Maxwell's equations by describing the force acting on a moving point in the presence of an electromagnetic field. First, make sure that the power is set to the off position. Next, turn on the power and check that the tube filaments are illuminated. Allow enough time for the cathode to heat up. This should only take a few minutes. Now, slowly increase the voltage dial to about 100 volts. At this point, a continuous horizontal beam of electrons will appear from the electron gun. Next, set the magnetizing current direction switch to the clockwise direction and adjust the current to about an amp. This establishes a magnetic field between the coils, with flux parallel to the axis of the coils. As you can see, the electron beam becomes a circular path inside the tube once it is immersed in the magnetic field. Now that we're set up, you can take measurements to calculate the radius of the beam of electrons with different voltages. With this, you can later calculate the charge-to-mass ratio of the electron. Start by setting the magnetizing current to 1 amp and then slowly increase the right voltage dial from 0 to 100 volts. You will do the same for amps at 1.25, 1.5, 1.75, and 2 amps later. Position your eye directly in front of the left side of the beam's arc. Slide the index along the scale until it is positioned directly in line with the left side of the curve. You may need to adjust the height of the scale. Record the position of the left side index, then move the index to the right side and record the data on your data sheet. You can either create your own or download ours through the link below this video, as well as on our website under Teachers Resources section. To calculate the diameter, take the difference between the left and right index positions. The radius of the beam is half the diameter. Now we will continue by adjusting the amps to 1.25, 1.5, 1.75, and 2 amps while keeping the voltage at 100 volts. Remember to always start over at 0 when adjusting these values. Then we will increase the voltage to 125, 150, 175, and 200 for each amp value. At this point, you should have completed the left and right index value for each of the voltage and current settings. With your collected data, you will be able to calculate a number of different things, such as the velocity of the electrons, the magnetic flux density, and the mass of the electron. So that's the Lorentz force experiment. If you enjoyed this video, click the like button. Also, be sure to subscribe to our channel and click the notification bell so you don't miss when our next video posts. Until next time, have fun learning.